Alright, so today we're going to be learning how to do some absolute graphs of functions. So our learning intention is we want to figure out the skill of sketching the absolute value function when given a different function. So we're going to give you a function, we want you to draw its absolute version. Okay, here are some of the success criteria. We should be able to correctly sketch y equals the absolute of f of x, and correctly sketch y equals f of the absolute of x. And we need to notice a couple of things. So when we're going to sketch the y equals the absolute f of x, when f of x is less than 0, we reflect that portion of the graph in the x-axis, and the rest of the graph stays the same. And when we're going to notice when sketching f absolute of x, when f of x is greater than 0, then reflect whatever that is around the y-axis to obtain the rest of the graph. Okay. So in order to do this, we need to be able to correctly use algebraic skills to help find key features as x and y intercepts, axes of symmetry of our original function, and then use our sketching techniques. Okay. A couple of examples. Okay. We want to sketch the absolute f of x and y equals f absolute of x if f of x equals 2x plus 3. So this is a linear relationship. We can see that the gradient is 2 and the y-intercept is 3. So I'm just going to sketch that. So I'm going to just, so the standard f of x, we have a grade of 2x plus 3, means we have a gradient of 2 and a y-intercept of 3. And I'm going to do it in blue pen because I started with it. So okay, we've got y-intercept of 3, 1, 2, and 3. Okay, and a gradient of 2, which means for every 1 unit I go across, I go up 2. Yeah, because this is 2 over 1. So the rise of 2, 1, 2, the run of 1. Okay. And so using a ruler, must stress this, using a ruler, I am going to draw my function. Okay, y equals 2x plus 3, my linear function. Alright. With my black pen, I want to figure out green pen, y equals the absolute of f of x. And basically this is stating where my function is always going to be positive. Yeah, so where the function is always going to be greater than or equal to 0. Okay, so what I do is I notice where it cuts my original function, where it cuts the x-axis. So what I really want to be doing here is I want to find when y equals 0. Okay, so I can figure out, so 0 equals 2x plus 3 minus 3. So it happens at negative 1.5. And you can see that because here's negative 1 and here is negative 2. Okay, so that is my y-intercept, sorry, my x-intercept. And what I want to do is basically I want to reflect this, whatever this is, around the x-axis. I want to flip it. So what happens is that, if I can get it correct, yeah, that looks right. This part here is my y absolute 2x plus 3. because that's my function. The other function I want to do is y equals f function of x, absolute of x. And that means that we have y equals 2 absolute of x plus 3. Whereas in this case, this was actually y equals the absolute of 2x plus 3. See the difference? So it's only the x value which is an absolute. And what that actually means is that once we've passed the y-axis, we actually want to mirror whatever we see on the right. Yeah, because these values here should just become positive absolute values. Okay, so if I start here, so 2, yep, and this part here becomes my y equals 2 absolute of x plus 3. Okay, so note when y equals the absolute of f of x, yep, rotate around the x-axis, and y equals f absolute of x, rotate around the y-axis. Okay, let's do example 2. Here we have a function. It's a quadratic. The first thing I want to do is actually factorize it. So I've got f of x should equal x minus 2 and minus 3 make positive 6, but minus 2 plus minus 3 makes minus 5, so minus 2x minus 3. Okay, so that's this function factorized. So that means my x-intercepts have to be 2 and 3, and my y-intercept when x equals 0, 0 minus 0 is 6. Okay, so I have 2 and 3 and 6. I know it's a positive parabola, so we'll go like this. I want to do my axes of symmetry. And the axis of symmetry will be the average of your two x-intercepts. So 2 plus 3 divided by 2 is 2.5. Yeah, so here's my axis of symmetry. I'm just going to draw it with a pencil. Yep. I'm going to plug in my 2.5 into my original, so when x equals 2.5, y equals 2.5 squared minus 5 lots of 2.5 plus 6. Alright, so 2.5 squared minus 5 lots of 2.5 plus 6 is negative 0.25. So my turning point happens here, 2.5 and negative 0.25. So that's somewhere here. Alright. So I'll just write it here. 2.5 minus 0.25. So what I have is technically parabola that looks like this. Okay. Now, when I want to find my absolute function, so when y equals the absolute of f of x, it means my entire function have to be greater than 0. So the only time it's not greater than 0 happens here. And so what I do is when I look at this, I will basically take the absolute of this stuff. So I'll stay at 2.5, but now rather than negative 0.25, I'm going to be positive 0.25. And I'm just going to basically connect it. So 2.5, 0.25. And this green function now that looks like a W is going to be my absolute function. So if I was to just do a quick sketch here, okay, I've got 2, I've got 3, this point here which is 2.5, 0.25, I've got here at 6, and so what it looks like is something that looks like this, so a W, okay. When I'm doing, that should be f, absolute of x, it means that all my x's are going to be positive. So I'll get rid of that. So what I do is I look at the original function, which went like this. Yeah. And I'm going to get at the y-axis and stop here. So I notice that we got 2.5. So if we think of f of x equals negative 2.5 squared minus 5 lots of negative 2.5 plus 6. Yeah, because I'm just going to have the negative version of that, because what I want to do is actually mirror it. So let's do that. The absolute of negative 2.5 squared minus 5 lots of the absolute of 2.5, negative, and plus 6 gives you negative 0.25. So over here, so actually over here, at negative 2.5, we have that same point here at negative 0.25. And so what happens, we have the mirror version around the y-axis, so it looks like a W. So if I was to sketch it, just a sketch, we have 2, we've got 2.5, negative 0.25, and we've got 3, up here at 6, here is your negative 2, here is your negative 3, here is negative 2.5, and negative 0.25. Yeah, so you get this W thing happening. Yeah, sorry, that's not to scale, but you get this W thing happening if you just basically flip that onto the other side. Okay, let's do one more example. So we've got the function x plus 2, x minus 1, x plus 3. So our x-intercepts happen at -2, +1, and -3. So -3, +1, and -2. Okay, so it's going to look something like that. The y-intercept happens at 2 times -1 times 3. So -2 times 3 is -6. So down here. Okay, so I'm doing something like this. I can come up somewhere here and go down this way. But I don't know where this point is, so we're going to find out. So that obviously it's going to be a turn, so the axis of symmetry at that point is obviously minus 2.5. So if we plug this in, so y would equal minus 2.5 plus 2, minus 2.5 minus 1, minus 2.5 plus 3. So minus 2.5 plus 2, minus 2.5 minus 1, minus 2.5 plus 3. So 0.875. So it's just somewhere here. Yeah. Okay. So that would be 0.875, negative 2.5. Okay. So we're saying that when y equals the absolute of f of x, yep, we're going to take any times it's below the axes, and we're going to flip it up. So we want 1, 2, 3, 4, 5, 6. Yep. And so what we're going to get, we're going to get something that looks like this. So once again, it looks like that. Okay. And now when we have f, so y equals f absolute of x, we're going to rotate it around the y-axis. So here's my original function. It crossed through 1, so my reflection will cross through 1, and basically it becomes a parabola of just this part here, because I'm rotating it around the y-axis. Yep. And so that's what you get. So you get something that looks from a N shape, we get a parabola. Okay, so the key important things to remember: the graph of the absolute f of x is always above or on the x-axis, so we rotate around the x-axis, and when we're rotating the graph of f absolute of x, it's symmetrical about the y-axis. So we see what's on the positive side of y, and we reverse it for the negative x values, and we reverse it around the y's. So looking back at our success criteria, we should be able to correctly sketch f of x absolute s of f of x, f absolute x, which one swaps over which, x or y axes. You need to be able to find your x and y intercepts for your normal function, your axis of symmetry, it's the average of both, and use our sketching techniques to figure that out. Okay, and that's the end of this lesson. Thank you.